स्टूडेंट्स, इस पार्ट में आज हम लोग पढ़ेंगे कूलम्ब्स लॉ. व्हाट इज कूलम्ब्स लॉ इन इलेक्ट्रोस्टैटिक्स? फॉर दिस वी हैव टू नो अबाउट द पॉइंट चार्जेस. डू यू नो अबाउट पॉइंट चार्ज? Point charge is that charge whose magnitude is very small than that of the separation between them. That is, point charges are that charges whose magnitude is very small than that of separation between them. Coulomb's law only valid for point charge. Suppose we have 2 point charges Q1 and Q2. Separation by a distance r. The force interacting between them is directly proportional to the product of their magnitudes and inversely proportional to the square of the distance. This is the law. So it states that the interacting force, it may be attractive or repulsive according to the charge, like or unlike. Taking force, interacting force between 2 point charges. 2 point charges is directly proportional to the product of their magnitudes and inversely proportional to the square of the distance between them. This force always acts along line joining the two charges. Consider 2 point charges Q1 and Q2 separated by a distance r in vacuum or air. The interacting force between them is F. Then from Coulomb's law, we can write F directly proportional to Q1 Q2 and inversely proportional to a square of the distance. This is also known as inverse square law. We can write here inverse square law. If we combine it, that is combining this F directly proportional to Q1 Q2 divided by R square. A proportional sign is eliminated by a constant q1 q2 by r square k is force constant and it depends on the nature of the medium of separation of charges and units of the system. K equal to 1 upon 4 pi epsilon naught. Its value is fixed 9 into 10 to the power 9 Newton meter square per coulomb square. Now, force. We can write here the value of K 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. Q1, this is the magnitude of the charge. So we can write here Q1 and Q2. This is coulombs now. Here epsilon naught. It reads as epsilon naught. It is known as the absolute permittivity. It is called absolute permittivity of free space. How can we find its value? Note, that is epsilon naught equal to 1 upon 4 pi f q1 q2 divided by r square. If we have to find its dimension and unit, we can write here. For dimension, at first we find its unit 1. 4 pi constant quantity, no unit. Force as Newton unit. Charge as coulomb into coulomb divided by distance. Distance, that is meter square. It form here coulomb square per Newton meter square, or we can write here coulomb square per Newton per meter square. If we have to find its dimension, then we can write here 1 force MLT minus 2 charge 80 into 80 and distance, that is L2. If we summarize here, we find that M minus 1, L1 and 2, 3 minus 3 and T is T to the power 4 A power 2. This is the dimension of epsilon naught. From this, we also find the dimension and value of K. Here, K equal to 1 upon 4 pi epsilon naught. It means K is equal to 1 upon epsilon naught. But it clearly shows that the epsilon naught value, unit of K, is opposite of epsilon naught, that is Newton meter square per coulomb square, or we can write here Newton meter square coulomb square. Its dimension of K, M L3 T minus 4 A minus 2, that is reciprocal of K or epsilon naught. We can find the value of epsilon naught 1 upon 4 pi K. 1 upon 4. Value of pi 3.14 and K 9 into 10 to the power 9. We find its value 12. 8.85 into 10 to the power minus 12. And its unit, we already know about it, coulomb square per Newton per meter square. This is the value of epsilon naught.